Docker. Docker overview. Estimate reading time 10 minutes. Docker is an open platform for developing, shipping and running application. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. With Docker you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. The Docker platform. Docker provides the ability to package and run application in a loosely isolated environment called a container. The isolation and security allow you to run many containers simultaneously on given host. Containers are lightweight because they don't need the extra load of hypervisor, but run directly within the host machine's kernel. This means you can run more containers on a given hardware combination than if you were using virtual machines. You can even run Docker containers within host machines that actually virtual machines. Docker provides tooling and platform to manage the life cycle of your containers. Develop your application and its supporting components using containers. The containers becomes the unit for distributing and testing your application. Then you already deploy your application into your production environment as a container or orchestrated service. This works the same whether your production environment is a locally data center, a code provided or hybrid of the two. Docker Engine. Docker Engine is a client-server application with their major components: a server, which is types of long-running program called a daemon process, the Docker command, a REST API, which specifies interface that program can use to talk to the daemon and instruct it what to do, a command line interface client, the Docker command, container managers, image managers, network managers, data volumes managers, client Docker, REST API, server Docker daemon. The CLI uses the Docker REST API to control or interact with the Docker daemon through scripting or direct CLI command. Many other Docker's applications use the underlying API and CLI. The daemon creates and manages Docker objects such as images, containers, network, and volumes. Note: Docker is licensed and under the open source Apache 2.0 license. For more details, see Docker architecture below. What can I use Docker for? Fast, consistent delivery of your application. Docker streamlines the development lifecycle by allowing developers to work in standardized and environments using locally containers. which provide the applications and services. Containers are great for continuous integration and continuous delivery workflow. Consider the following example scenario. Your developers write code locally and share their work with their colleagues using Docker containers. They use Docker to push the application into test environment and execute automated and manual test. When developers find bugs, they can fix them in the development environment and redeploy them to the test environment for testing and validation. When testing is completed, getting the fix to the customer is as simple as pushing an updated image to the production environment. Running more workloads on the same hardware. Docker is lightweight and fast. It provides a viable, cost-effective alternative to hypervisor-based virtual machine, so you can use more of your compute capacity to achieve your business goal. Docker is perfect for high density environments and for small and medium deployments where you need to do more with few resources. Docker architecture. Dockers use a client service architecture. The Docker client talks to the Docker daemon, which does have lifting of building, running and distributing your Docker containers. The Docker client, the daemon, can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and daemon communicate using a REST API over Unix sockets on network interface. Client, Docker build, Docker pull, Docker run, Docker host, Docker daemon, image, containers, Jinx, registry. Okay. The Docker daemon. The Docker daemon, Docker D, elicit for Docker API request and manages Docker objects such as images, containers, networks, and volumes. A daemon can also communicate with other daemons to manage Docker service. The Docker client Docker is a primary way to that many Docker's users interact with Docker. When you use commands such as Docker run, the client sends commands to Docker which carry them out. The Docker commands uses the Docker API. The Docker client can communicate with more than one daemon. Docker registers. A Docker register stores and Docker images. Docker Hub is a public register that anyone can use, and Docker is configured to look for images on Docker Hub by default. You can even run your own private registry of use Docker data center included Docker trust register. When you use Docker pull or Docker run command, the required image is pulled from your configured registry. When you use Docker push command, your image is pushed to your configured registry. Docker objects. When you use Docker You are creating and using images, containers, networks, volume, plugins and other objects. This section is a brief overview of some of these objects. Images. An image is a read-only template with structure for creating a Docker container. Often an image is based on another image with some additional customization. For example, you may build an image which is based on Ubuntu image but install the Apache web server and your application, as well as configuration details needed to make your application run. You might create your own images, or you might only use those created by others and publish it in a registry. To build your own image, you create Docker with simple syntaxes for defining the steps needed to create the image and run it. Each instruction in Docker file creates a layer in image. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. This is part of what makes image so lightweight, small and fast when compared to other virtualization technologies. Containers. A container is a runnable instance of an image. You can create, start, stop, move or delete container using the Docker API or CLI. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. By default, a container is relative well isolated from other containers and its host machine. You can control how isolated a container's network, storage or other underlying subsystems from other containers or from host machine. Container is defined by its image as well as any configuration options you provide to it when you create or start it. When a container is removed, any changes to its state that are not stored in persistent storage disappear. Example: docker run command. The following command run as Ubuntu container attached interactively to your local command line store and run bin bash. Docker run it ubuntu bin bash. When you run this command, the following happens. Assuming you are using the default registry configuration, if you do not have the Ubuntu image locally, Docker pulls it from your configured registry as though you had run docker pull Ubuntu manually. Docker creates new containers as though you had run a docker container create command manually. Docker allocates a read-write file system to the container as its finally layer. This allows running containers to create or modify files and directories in its local system. Docker creates networks interface to connect the container's default network since you did not specify any networking options. This including assigning an IP address to the container. By default, containers can connect to external network using host machine network connection. Docker starts a container and execute bin bash because the container is running interactively and attach it to your terminal. You can provide input using your keyboard while the output is logged to your terminal. When you type exit terminal bin bash command, the container stops, but it's not removed. You can start it again or remove it.